Hi guys, welcome to my channel Science to Scientist. Today we are going to learn about our new chapter is Matter Around Us Pure. I have brought you the brief notes of this chapter so to make this chapter easier understandable for you. So let's begin our session. Before that, I would recommend you to please read the book. So now moving forward. Matter. Everything in this universe that occupies space and has mass is known as matter. If you want to know more about matter, please just go and watch the previous video I have uploaded. I will be providing link in the description also. Mixture. A mixture contains more than one substance, that is element or compound, mixed in any proportion is called mixture. Example of a mixtures are pickle, pasteurized milk, etc. As you have seen, pasteurized milk, on their package it mostly written pure, but actually it is not, as pasteurized milk are the mixtures of oil, water, fats, proteins, etc. Now substances. Anything that cannot be broken into further particles by applying any physical process is called a substance. Example of substance are salt, sugar, tin, or etc. Types of mixture. There are two types of mixture, homogeneous and heterogeneous mixture. Homogeneous mixture. The substance in which the components are mixed with each other uniformly are called homogeneous mixture. Whereas heterogeneous mixture, the substances in which the components can be easily separated by physical means, such mixtures are called as heterogeneous mixtures. Now what is a solution? A solution is nothing but a uniform mixture of two or more substances. Homogeneous mixtures are solutions. Examples are lemonade, soda water, etc. We usually think solution contains either a solid, liquid or a gas dissolved in it. But we can also have solid solutions, alloys and gaseous solutions air. Liquid into liquid, that is water and ink. Solid into solid, example is alloys. Gas into gas, example is air. Solid into liquid, sugar and water. Solid into gases, hydrogen and metals. Liquids into gases is carbon dioxide and water. Now let us know about alloys. Alloys is the mixture of two or more metals or a metal and a non-metal which cannot be separated into their components by physical methods. For example, brass and bronze, where brass is the mixture of approximately 30% of zinc and 70% of copper. Solution constitutes of two types of substances known as solute and solvent, as solution is the sum of solute plus solvent. Let us know about solvent. The substance in which another substance is mixed is called solvent. Example of solvent is water is a solvent in which we can mix different substances. Now solute. The substance that is added to the solvent to form a solution is called a solute. For example, salt which can be mixed in water acts as solute for the mixture. Now properties of solution. A solution is homogeneous mixture. We cannot see the particles of the solution through naked eyes, as they are small as 1 nanometer in diameter. Due to small size, they cannot scatter a beam of light passing through the solution. We cannot separate the particles of a solution by methods of filtration. Now concentration of a solution. Depending upon the amounts of solute present in a solution, it can be called a dilute, concentrated or a saturated solution. Now let us know about dilute solutions. Solutions in which the concentration of the solute is much less than that of the solvent. For example, 1 gram of salt in 500 ml of water. On continuing adding the solute in a solution, a point comes when no more solute can be dissolved in solution. This is called saturation point of a solution. Saturated solution. A solution in which no more solute can be added as it has already maximum amount of solute, it is called saturated solution. Unsaturated solution. A solution in which we can add more amount of solute as it has not achieved the saturation level. Now concentration of solution. It is the amount of solute present in a given amount of solution or the amount of solute dissolved in a given mass or volume of solvent. Concentration of solution is equivalent to amount of solute by amount of solution. There are various ways of expressing the concentration of solution. A. By mass percentage of solution, which is equivalent to mass of solute by mass of solution into 100. B. By mass of volume percentage of solution, that is mass of solute volume by volume of solution into 100. Now, what is a suspension? A suspension is a heterogeneous mixture in which the solute particles do not dissolve but remain suspended throughout the bulk of the medium. Properties of suspensions are: it is heterogeneous mixture, particles can be seen by naked eye, scatters beam of light passing through it, and they can be separated from the mixtures by the process of filtration. Now, what is a colloidal solution? A colloidal solution or a colloid is a uniform solution of two or more substances. The particles are relatively very small, that the solution appears as homogeneous mixture, but it is not. For example, milk. Now, properties of colloid. Colloids are heterogeneous mixtures. The size of the particles of colloids is too small, making it individually seen by naked eye. The particle scatters beam of light, passes through it and produces Tyndall effect. Colloids are stable in nature. The particles of colloid do not settle down if left uninterrupted. Particles cannot be separated from the mixture by the process of filtration, but special techniques of separation known as centrifugation can be used to separate the colloidal particles. As you can also see in the figure that a flashlight passes through the passes through the colloid and partially passes through the suspension. Now, what is a Tyndall effect? When a beam of light is passed through the colloidal particles of colloid, scatters the beam of light and we see the path of light in the solution. For example, when a ray of light passes in a dark room. Now, classification of colloids. It is of two types, dispersed phase and disposing medium. So, dispersed phase. The disposed particle component in a colloid is known as dispersed phase, and disposing medium, the substance in which the solutes-like particles are added, is called disposing medium. Common examples of colloids are dispersing medium having gas, dispersed substance having liquid, and colloid type is aerosol. An example is fog, aerosol or spray. Second example is smoke, airborne bacteria from dispersing medium having gas and dispersed substance having liquid. So this type of colloid is aerosol. Third one is whipped cream, soap suds. Dispersing medium is here having liquids, dispersed substance is here gas, and the colloid type is foam. The fourth one is milk or mayonnaise. Here Dispersed medium is liquid and dispersed phase is liquid. So colloid type is emulsion. Now fifth one is paints, clays or gelatin. Here dispersed medium is liquid and dispersed substance is solid. For example, it is a sol type of colloid. Next one is marshmallow and styrofoam. Here dispersing medium is solid, dispersed substance is gas and colloid type is solid foam. Next one is butter cheese. Here dispersing medium is solid, dispersed substance is liquid and colloid type is solid emulsions. The last one is ruby glass, having dispersing medium as solid, dispersed substance as solid and the colloidal type is solid sol. Now separating the components of a mixture. We can separate the heterogeneous mixtures into their constituents by the means of physical methods like filtration, hand picking and sieving. The components of a mixture can be separated from each other using several other techniques like evaporation, centrifugation, sublimation, chromatography, distillation. So now let us see about evaporation. In this we will see its applications and the method by which it is happened. Evaporation. For separating a mixture of a non-volatile and a volatile substance. You can also see this in the figure. Its applications are separating colored components from the ink, or salt from water, or sugar from water. Its method is to mix some ink into water and heat it. After some time, the water will evaporate, leaving behind the colored substance. Or when we heat salt from salt-sugar solution, then also we will left with the residues of salt. Now centrifugation, separating dense particles from lighter particles. Its applications are separating milk from cream, or separating butter from cream, or squeezing out water from wet clothes. Its method is, milk is put in centrifuging machine or milk churner and the cream thus separates from milk. Now the third method is using a separating funnel. In this, the two separates immiscible liquids. It is used to separate two immiscible liquids. As you can see in the figure, the two immiscible liquids, that is having low density above and the high density liquid is below. Its applications are to separate oil from water or iron from iron ore. Its method is, the immiscible liquids are allowed to settle in the funnel. They soon form separate layers due to varying densities. The first liquid is allowed to follow out of the funnel, and as soon as it is completely poured out, the stopcock is closed, thereby separating the two liquids from each other. Now the fourth method, sublimation. To separate a sublimable component from a non-sublimable component. As you can see in the figure also, this is the figure of a sublimating process. Its applications are to remove ammonia chloride, camphor, naphthalene and salts, etc. Its method is to heat the mixture in an inverted funnel so that the sublimable component sublimates in the air and settles over the wall of the funnel, and the non-sublimable components on the other hand is left behind. The fifth method is chromatography, to separate the solutes that can dissolve in the same solvent. As you can see in the figure, it's a process of chromatography. Its applications are to separating color components of a dye and drugs from the bloods. Its method is to take a filter paper or a blotting paper and place a drop of ink at the rear end. Dip the end in water. Since ink is a mixture of two or more colors, the component of ink which is soluble in water mixes into it and then separates quickly from the other components that are less soluble in water. The next method is distillation. It is used to separate miscible liquids, that is, the boiling point of the liquids must be sufficiently different. As you can clearly see from this figure, this is the process of distillation, where the water or the liquid is continuously heated, after which the condensed form of the water is received at the in the beaker after passing through the condenser. Its application is to separation of acetone and water and many more. Its method is to the mixture is heated in a distillation apparatus. The one substance with lower boiling point evaporates first, condenses and gets separated from the one with a higher boiling point. It is of simple. First we will talk about simple distillation, when the miscible liquids have a satisfactory difference in their boiling points. And second one is of fractional distillation, where the difference between the boiling points of the liquids is less than 25 Kelvin. Now we will talk about separating different gases from the air. Its method is fractional distillation. In this, compresses and cool the air by increasing the temperature and decreasing the pressure. The air turns to liquid air. Then liquid air is warmed up slowly in fractional distillation apparatus. These several components of air get separated and are collected at various heights on the basis of their boiling points. Now purifying solids by using the method of crystallization. In the crystallization method, we can obtain a pure solid in the form of crystals from its solution. You can see the image of crystallization happening with a impure solid having dissolved impure solids dissolved in a solvent, after which in second step the impure solution is continuously heated up and the hot solution is allowed to cool. In the third step, where the solids appear as the pure crystals, and in fourth step the crystals are filtered on the filter paper, leading the cold solution is poured off the bottom in the crystals. The crystals may be dried up by pressing them between sheets of filter papers, leading to get us pure crystals of the compound. Its applications are to separate salt from seawater or purifications of copper sulfate. Its method is the impurities of substance are filtered out. Water is evaporated to obtain a saturated solution. The solution is covered with filter paper and left as it is. After some time, the crystals of pure solids are formed. Now you might be thinking, is evaporation better than crystallization? Simple evaporation is not better than crystallization because some solid substances decomposes because of excess heat. For example, sugar gets charred on extra heating, and if after filtration some impurities remain in the solution, they can contaminate the solid and therefore we would not obtain a pure substance. Now we will study about physical change and chemical change. Now physical properties of a substance. Properties of a substance such as rigidity, color, fluidity, boiling point, melting point, density and hardness, which we can observe, are called as physical properties. Physical changes. When physical properties of a substance change, it is known as physical change. When we convert a substance from one state to another, such as solid into liquid or vice versa, it is also a physical change, as only the physical nature of the substance changes without affecting its chemical nature. For example, change of ice to water, the chemical properties of water remains the same. Now chemical properties of a substance. The chemical nature of a substance is known as chemical property, such as its order or its chemical compositions. Now chemical change. When the chemical properties or chemical compositions of a substance gets altered, it is called a chemical change. It is also called as chemical reactions. For example, burning of a paper. In this figure, you can see the physical change of water into ice and the chemical change of hydrogen peroxide into water. Now, types of pure substances. Pure substances are classified as elements and compounds. Elements. An element is the simplest form of matter, and elements cannot be broken down into further elements by chemical reactions. Elements are further characterized as metals, non-metals, and metalloids. Metals. Examples are silver, mercury, copper, gold, and many more. Metals are lustrous, that is, they are shiny. Metals conduct heat and electricity. Third point is metals have a silver grey or gold yellow color. Fourth is we can hammer metals and form thin sheets, that is, it shows malleability. Fifth one is we can convert metals into wires, that is ductility. And the sixth is metals always produce a ringing sound if they are hit, that is, they are sonorous. Now, non-metals. Carbon, iodine, chlorine, oxygen, and hydrogen are various examples of non-metals. Non-metals do not conduct heat and electricity. They are not sonorous, lustrous, or ductile. Non-metals have varied colors. Now, metalloids. Examples are silicon and germanium. They show some properties of metals and some properties of non-metals. Now, some quick facts. Now, let us start for compounds. It is a substance consisting of two or more substances. These substances are combined chemically with each other in fixed proportions. The properties of compounds are different than that of its constituents. For example, ammonium sulfates, sulfur chloride, water are examples of compounds. Below, I have tabulated mixtures and compounds. So let us study about it. Mixtures. Mixtures properties of mixture reflect the properties of the materials it contains, whereas compounds different properties from that of the elements that make up the compounds. Mixtures no uniform compositions, whereas in compounds definite composition, that is definite ratio or formula. Mixtures can be separated by physical means, whereas compounds cannot be separated by the physical means. Here is the another tabular form of mixture versus compound. Now, moving further, matter is distributed into two types: pure substances and mixtures. Pure substances are further divided into elements and compounds, whereas mixtures that have no fixed compositions are separated into two types, that is homogeneous and heterogeneous. Now let us talk about elements. Elements cannot be broken down to simpler substances, that is, they are the smallest part, and after which it cannot be broken into many further parts. Example for it is copper, oxygen, iron, hydrogen, mercury, etc. Whereas in compounds have the fixed compositions, that is, they can be broken down into elements by chemical or electrochemical reactions. That is, compounds are the fixed compositions of various elements combined together, that is, H2O is an compound. Here, for example, there are water, methane. Methane have the chemical formula of CH4, sugar, salt, etc., and many more. Now, homogeneous mixtures. Homogeneous mixtures are those which are uniformly compositions. That is, the solutions is uniformly distributed in this solution. For example is sugar in water, salt in water, sulfur in carbon disulfide, water and alcohol, etc. And the last one is heterogeneous mixture. In this, it is a non-uniform composition. That is, the solute is not evenly distributed in the solution. Examples of it are sand and salt, sugar and salt, wood and blood, water in oil, etc. By this, we have finished our second chapter, Is Matter Around Us Pure? So please like, subscribe, share and press the bell icon to get regular updates for the videos. Thank you.